Hey guys, Mr. Mailhot here. Do a little pre-calculus. We are working on finding rational zeros of polynomials using the rational root test, those P's and Q's. So we're going to do one of our homework questions together, and you can use this to help you with your other ones, and combined with your notes, you should be good for our quiz. So here's what we got to do. Use the degree to decide the end behavior. Use the leading coefficient. And then use the leading coefficient to work on the end behavior. If it's factored, we can graph it pretty quick, but we're going to do one that's not factored, so we'll have to use this rational root test that we've been talking about and synthetic division. Then write it in factored form and sketch a graph. Let's do the one that's on the end of our homework, the very last one. All right. So this is not factored form, right? There's no factors here. These are just separate terms. So the first thing you might think, and what you should have done with most of the rest of them, is look at your P, right? The constant term. Look at Q, the leading coefficient, and start listing out those factors of each. However, in this case, we have a GCF. It's always good to look for a GCF. Do you see that there's something we can take out of each term? It's always good to check the leading coefficient. Yeah, we can factor a 2 out of each term. So let's rewrite it. 2 times all of this stuff. Now the x's stay to the same degree because we're not dividing out an x. We're not factoring out an x. We're just factoring a 2 out of each term. So divide each term by 2. Okay, now we can start with our P's and Q's with this stuff, what was left over. Well, for Q, shoot, there's only one factor of 1. It's 1. For P, we're with 15. Let's see, we've got 1, 2, 3, 4, no, 5, yes. 6, 7, 8, 9, 10, nope, up to 15. I think those are all our factors, right? And then a good way to check is these should match up. 1 times 15 is 15, 3 times 5 is 15, we're good. So our possible roots could be plus or minus 1 over 1, or 1, plus or minus 3 over 1, or positive negative 3, 5, or 15. So those are our possible, let me make a better 5. Those are our possible roots. 1, 3, 5, and 15. We got to check some now. You might run out of space. That's fine. Do some scratch work. Get a different piece of paper. I'm just going to use a different piece of paper. Let's check 1 first. We're going to check positive 1. It's easy to check positive 1. Here we go. What goes here are the coefficients. Now, we got to use the coefficients from what was left over after we factored out our greatest common factor, because that's where we took our possible roots from as well. So 1, 9, 23, 15. Those are the coefficients of that quotient that's left over. The synthetic division, drop it like it's hot, bring down the first 1. It's 1. 1 times 1 is 1. Add those, 10. 1 times 10 is 10. Add them, 33. This doesn't look like it's going to work out, huh? Because 1 times 33 is 33. And if you add this, this is not 0. So 1 is not a root, or x minus 1 is not a factor. Darn, too bad. Let's test another one. Normally, if you're doing your scratch work, you could just erase all this stuff, but I'm going to leave it because it's good to reference. Let's try negative 1. We've tried 1, let's try negative 1. Negative 1. Same setup, same coefficients go here. 1, 9, 23, 15. Same process. Bring down a 1. Now we're multiplying by negative 1 now, so negative 1 times 1 is negative 1. Add these together and you get 8. Negative 1 times 8 is negative 8. Add those together. You get 15. Ooh, I think this one might work out right, because negative 1 times 15 is negative 15 and we get a 0, we get no remainder. That is good. That means that negative 1 is a root, and x plus 1, remember they're kind of opposites just like here, x plus 1 is a factor of f of x. So let's rewrite where we're at. We just found that x plus 1 is a factor. So we've got 2, our greatest common factor. We've got an x plus 1 as the factor we just factored out. Now what is the rest that's left over? Well, remember it comes from, slide up here, remember it comes from our answer down here. These represent coefficients of what's left over after we divided, right? When you divide, you get stuff left over. We just divided, here's what's left over. We went from an x to the third polynomial. We divided out one x term with this factor, so this is going to be an x squared, or x to the second polynomial. 1x squared, these are the coefficients of it, 1x squared plus 8x plus 15. Okay, we're not done though, because I mean we have one factor, we want to factor it all the way. Now we could continue with synthetic division and test, we tested plus and minus 1, we're done with that one. We could test these ones, but I think we can factor this. Like, what are some numbers that multiply to give you 15 and add to give you 8? Heck yeah, 3 and 5. And then we still have this other factors that we left over that we divided out earlier. So in factored form, this is your factored form. In factored form, f of x is 2 times x plus 1 times x plus 3 times x plus 5. That is factored form. We found our roots. We had to check a couple. Really, we got lucky because we had to only check 1 and it didn't work, and we checked negative 1 and it did work, which gave us this factor. Had to factor this the rest of the way. We kind of just did it in our heads, and here we go. There's our factored form. Let's graph it in a second. Let's talk about the end behavior of this, because you could actually decide the end behavior from the very beginning. Remember, end behavior is written like this. As x approaches infinity, what happens to f of x? And as x approaches negative infinity, what happens to f of x? What do you think? Even or odd degree? Odd. The highest exponent is odd. So that means we're going to have opposite directions of end behavior. And in fact, it's going to be finishing in the positive direction, right? On the right-hand side of our graph, it's going to be finishing up here somewhere up there, because this is leading coefficient is positive. So we got odd, positive. So as x approaches positive infinity, right, on our graph, as it approaches positive infinity, it'll be going positive towards infinity. And since it's opposite, if we go the opposite direction, it'll be going down towards the opposite direction. So here's your end behavior. So we've factored it, we found the roots, we've got the end behavior, we just got to graph it. This tells you where our roots are. Our factored form does. We got a root at negative 1, we got a root at negative 3, we got a root at negative 5. Right, what would make these equal to 0? These numbers. Let's plot them. Negative 1, there's negative 1, 2, and 3, negative 3, 4, 5, negative 5. Here are our roots. And actually, we do know the y-intercept. Go back to your original equation. The y-intercept is always that constant term. So now we don't have a scale here, so I'm just going to mark it here that that's 30. We'll have our scale be a little off. That's fine. So we said it was going to end positive. We got to kind of shift over a little bit because we got nothing going on over here. So it's going to end in the positive direction like that. And on the left-hand side, end in the negative direction. What goes on in the middle? Well, each of these factors are just to the first degree. There's no exponents on them. So their multiplicity is just 1. they're going to cross through on each one of those. If you're not sure about multiplicity, go on YouTube, type in graphing polynomials with multiplicity, you'll find some videos. We cross, we cross, we cross, and that is a pretty dang good looking graph. Alright guys, good luck on your quiz. Come with questions next time. Remember, we're mathematicians, we could do anything we want. See you later.